Many people hear Ethereum and think of Ether. Ether or ETH is a digital currency. However, Ethereum is much more than just this coin. Viewing it solely as a cryptocurrency is a very narrow perspective. Ethereum represents a fundamental shift in how we can use blockchain technology. It is a global open-source platform designed for a new generation of applications. These applications are decentralized, meaning they are not controlled by a single entity. Think of Ethereum as a special kind of computer. This computer is not located in one place. Instead, it is made up of thousands of computers around the world. These computers work together to run the Ethereum network. This concept is often called a world computer. No single company or person owns this world computer. It is maintained and operated by its global community of users and developers. This distributed nature makes it incredibly resilient and transparent. Ethereum allows developers to build and deploy innovative software. These are known as decentralized applications, or dApps. dApps run on the Ethereum blockchain. This means their operations are recorded transparently. Ethereum was first conceived in late 2013. Its primary architect was Vitalik Buterin. At the time, Buterin was a young programmer and a writer for Bitcoin magazine. He recognized the groundbreaking potential of Bitcoin. However, he also saw its limitations. Bitcoin was designed primarily as a peer-to-peer electronic cash system. Buterin envisioned a blockchain that could do much more than just process financial transactions. He wanted a more general-purpose platform. Buterin proposed a new blockchain. This blockchain would have a built-in, Turing-complete programming language. This would allow developers to write and deploy smart contracts. Smart contracts could then be used to create any kind of decentralized application imaginable. He detailed this ambitious vision in the Ethereum white paper. The paper described a platform for building unstoppable applications. It aimed to extend blockchain capabilities beyond simple currency. To bring this vision to life, the Ethereum project launched a pre-sale. This pre-sale, or crowd sale of Ether tokens, took place in the summer of 2014. The funds raised were used to finance the development of the platform. The Ethereum network, in its first live iteration known as Frontier, officially launched on July 30, 2015. Smart contracts are the cornerstone of Ethereum's functionality. The term might sound like a legal document. However, smart contracts are actually computer programs. These programs are stored and executed on the Ethereum blockchain. They are designed to automatically enforce the terms of an agreement. The concept was first introduced by cryptographer Nick Szabo in the 1990s. Ethereum was the first platform to implement it effectively at scale. Imagine a smart contract as a highly sophisticated digital vending machine. You interact with it by sending cryptocurrency, an input. The smart contract then automatically executes its pre-programmed logic. It might dispense a digital asset, register ownership, or trigger another action, an output. All of this happens without needing a human intermediary. The code itself is the enforcer of the rules. This creates a trustless environment where trust is in the code, not in a central party. Developers write smart contracts using specific programming languages. The most common language for Ethereum is Solidity. Once a smart contract is written and tested, it is deployed to the Ethereum blockchain. After deployment, the code of the smart contract becomes immutable. Smart contracts are not just theoretical constructs. They are the engine powering a diverse ecosystem of decentralized applications, or dApps. One of the most significant areas transformed by smart contracts is finance. Decentralized finance, or DeFi, aims to rebuild traditional financial services. These services include lending, borrowing, trading, and insurance. DeFi applications use smart contracts to manage these operations without needing banks or other financial institutions. Users can interact directly with the protocols. Another prominent application is the creation and trading of non-fungible tokens, or NFTs. NFTs represent verifiable ownership of unique digital or physical assets. These can be digital art, collectibles, music, virtual land, or even event tickets. Smart contracts define the properties of each NFT. They also govern how NFTs are created, minted, sold, and transferred. This has provided new avenues for artists and creators to monetize their work. It has also created new forms of digital ownership. Decentralized autonomous organizations, commonly known as DAOs, are also built using smart contracts. DAOs are essentially internet-native organizations. Their rules and governance mechanisms are encoded in smart contracts. Section 5. the merge a greener, more efficient Ethereum. For many years, Ethereum operated using a consensus mechanism called proof of work, or POW. This is the same system that Bitcoin uses to validate transactions and secure its network. In POW, miners use powerful specialized computers. These computers compete to solve complex mathematical puzzles. The first miner to solve the puzzle gets to add the next block of transactions to the blockchain. They receive newly created ETH as a reward. However, POW is notoriously energy-intensive. The high energy consumption of POW was a significant concern for Ethereum. It limited the platform's sustainability and environmental friendliness. In response, Ethereum developers embarked on a multi-year project. This ambitious upgrade was known as the merge. Its goal was to transition Ethereum from proof of work to a different consensus mechanism. This new mechanism is called proof of stake, or POS. The merge was successfully completed on September 15, 2022. It was a historic and complex technical feat. Under proof of stake, the process of validating transactions and creating new blocks changes dramatically. Instead of miners, POS relies on validators. Validators are users who lock up, or stake, a certain amount of ETH. By staking their ETH, they get a chance to propose and attest to new blocks. Section 6. Layer 2 Scaling Solutions, expanding Ethereum's horizons. As Ethereum gained popularity, its network faced growing pains. Increased usage led to network congestion. When many people try to make transactions at the same time, the network slows down. This also causes transaction fees, known as gas fees, to rise significantly. At times, these fees became very expensive. This made using Ethereum impractical for small transactions or for users with limited funds. These scalability limitations were a major hurdle for widespread adoption. To overcome these challenges, the Ethereum community developed Layer 2 scaling solutions. Layer 2s are separate blockchains. They are built to operate on top of the main Ethereum blockchain, or Layer 1. Their purpose is to process transactions off the main chain. This helps to reduce the load and congestion on Layer 1. Layer 2 solutions bundle many transactions together. They then periodically submit a summary or proof of these transactions back to the Ethereum mainnet. This ensures that Layer 2 transactions still benefit from Ethereum's security. There are several types of Layer 2 solutions, each with different technical approaches. One popular category is optimistic rollups. Prominent examples include Arbitrum and Optimism. They are called optimistic because they assume transactions are valid by default. Section 7. ETH, the fuel and foundation of the ecosystem. Ether, or ETH, is the native digital currency of the Ethereum platform. It is much more than just an asset for speculation. ETH plays several fundamental and indispensable roles within the Ethereum ecosystem. Its utility is deeply integrated into the network's operation. Without ETH, the Ethereum world computer could not function. It serves as the economic incentive layer that keeps the network running smoothly and securely. It is the lifeblood that powers every action on the platform. The most direct utility of ETH is for paying gas fees. Gas refers to the computational effort required to execute a transaction or a smart contract function on Ethereum. Every operation, from a simple ETH transfer to a complex DeFi interaction, consumes gas. Users must pay for this gas in ETH. These fees compensate the validators, previously miners, for their work in processing transactions and securing the network. Gas fees prevent spam and allocate network resources efficiently. Since the merge and the transition to proof of stake, ETH has gained another crucial utility: staking. Section 8. Navigating the hurdles. Ethereum's ongoing challenges. Despite its remarkable progress and widespread adoption, Ethereum is not without its challenges. The issue of high gas fees on Layer 1, especially during periods of intense network activity, continues to be a concern. While Layer 2 solutions offer significant relief, the user experience of moving assets between layers can sometimes be complex. Ensuring that Ethereum remains accessible to users worldwide, regardless of their financial capacity, is an ongoing effort. The scalability trilemma balancing decentralization, security, and scalability remains a core focus. Concerns about potential centralization risks also persist within the Ethereum ecosystem. For instance, a significant portion of staked ETH is concentrated in a few large staking pools and liquid staking protocols. This could potentially give these entities undue influence over network consensus if not carefully managed. Similarly, The reliance on a small number of infrastructure providers for services like node hosting and API access is another area of scrutiny. The Ethereum community is actively researching and implementing measures to mitigate these centralization vectors and uphold the network's core principles. The blockchain space is highly competitive. Section 9. Conclusion. Ethereum's enduring evolution and Web3 leadership. Ethereum has profoundly reshaped the landscape of blockchain technology. It has evolved far beyond its initial perception as just another cryptocurrency. Today, Ethereum stands as a robust, versatile, and programmable platform. It is a foundational layer for the emerging decentralized internet, often referred to as Web3. Ethereum provides the essential tools and infrastructure that empower developers to build this new digital frontier. Its smart contract capabilities are fostering innovation across a multitude of sectors, from finance to art to governance. The journey of Ethereum, from its conceptualization by Vitalik Buterin and its launch in 2015, has been extraordinary. It has been marked by continuous research, development, and adaptation. The successful execution of the merge in 2022, transitioning the network to proof of stake, was a monumental achievement. This upgrade not only drastically reduced Ethereum's energy footprint, but also set the stage for further enhancements. The ongoing development and adoption of Layer 2 scaling solutions are actively addressing the network's capacity limitations, making it more accessible and user-friendly. Challenges undoubtedly remain. Issues such as gas fee volatility, potential centralization pressures, and the competitive environment require constant attention and innovative solutions. However, the Ethereum community is one of its greatest strengths. It is a global, diverse, and highly engaged collective of researchers, developers, and users.